What if you could travel back in time to the very first second of existence, not to watch, but to listen? Imagine standing at the edge of the beginning. There are no stars, no galaxies, no planets. There is only energy, a screaming, hot, dense ocean of plasma. For decades, we believed the beginning of the universe was silent and invisible. But we were wrong. The universe left behind a message, a fingerprint, etched into the sky itself. Today, we are going to read that fingerprint. We are going to explore the cosmic microwave background, the oldest light in existence, and decode the story of our origin. To understand this signal, we need to understand what the infant universe was truly like. For the first 380,000 years after the Big Bang, the universe was a prison. It was so hot and so dense that light itself could not travel freely. Photons, particles of light, were constantly colliding with free-floating electrons. The universe was filled with a glowing fog, an opaque ocean of radiation. If you had been there, you would not have seen empty space. You would have been blinded, immersed in a wall of white fire. But then, something changed. As space expanded, it cooled. When the temperature dropped to about 3,000 Kelvin, protons and electrons bonded together to form the first neutral hydrogen atoms. This moment is called recombination, and it changed everything. Suddenly, electrons were no longer blocking light. The fog vanished. The universe became transparent, and in that instant, all the trapped light was released, flashing outward in every direction at once. That flash is still traveling today. Over billions of years, as space continued to stretch, that brilliant white light stretched with it, shifting from visible light into infrared, and eventually into microwaves. Today, this ancient glow washes over Earth from every direction, every second of every day. In fact, if you turn an old analog television to a dead channel, about 1% of that static is the afterglow of the Big Bang interacting with your antenna. You are watching the ghost of creation. But astronomers did not want to just detect this light. They wanted to map it. When space telescopes surveyed the sky, they did not find a smooth, uniform glow. They discovered something far more profound: imperfections. This is the most important image in the history of cosmology. At first glance, it looks like random noise, a speckled pattern of blue and orange. But this is the baby picture of the universe. Each color represents an unimaginably tiny difference in temperature, less than 1 part in 100,000. These fluctuations are not errors. They are seeds. Slightly cooler regions were slightly denser, and density means gravity. Those denser regions pulled in more matter. Over millions of years, they grew heavier. Over hundreds of millions, they collapsed. And from those collapses, the first stars ignited. If the early universe had been perfectly smooth, nothing would have formed. No stars, no galaxies, no planets. The universe would be cold, dark, and lifeless. You exist because the early universe was not perfect. But the map revealed something else, something unsettling. When physicists analyzed these patterns, they discovered a problem. Normal matter, the atoms that make up stars and gas, does not have enough gravity to form structures this quickly. The universe should not look the way it does. Something else was shaping it. The cosmic microwave background provided the first powerful evidence for dark matter, an invisible substance whose gravity dominates the universe. By listening to the ancient sound waves frozen into this light, Scientists calculated the true cosmic recipe. Less than 5% of the universe is normal matter. About 27% is dark matter, and nearly 68% is dark energy, a force pushing the universe apart. This is not just a photograph of the past, it is a blueprint of reality. And the story continues. Right now, new observatories are being built to listen even more closely, not just to temperature, but to polarization, subtle twists in the light itself. These patterns, called B-modes, could reveal primordial gravitational waves, ripples in space-time generated during the universe's first fraction of a second. If detected, we would not just be seeing the afterglow of creation. We would be witnessing the moment the universe began to expand. The universe is 13.8 billion years old, but its memory is flawless. Every time we look into empty space, we are looking into a record of ourselves, a story written in light, shaped by gravity, and carried through time. This map is our origin story, written across the sky. If you want to explore more of the invisible universe, subscribe to Oblyxar.